So what exactly are basic trigonometric identities? They are simply equations which relate trigonometric functions. In this video, we'll deal with basic functions, that is basic trigonometric identities. So the two identities we'll look into are these. This is the first identity, that is tan x is equal to sin x over cos x. These identities did not just fall out of the sky, instead they were derived. For example, sin x over cos x is equals to perpendicular over hypotenuse for sine, and cos x is base over hypotenuse. The hypotenuse cancels out, we are left with perpendicular over base, which is tan. Then we have our second identity. Sin square x plus cos square x is equals to 1. You need not know the derivation for this. And this can obviously be rearranged. Now before I move on, I'd just like to clarify the fact that similar to the first identity, if we had tan square x, in this case it would be sin square x over cos square x. Just appreciate the fact that both sides have been squared. Then why do we need trigonometric identities? We either need them because they are embedded into a trigonometric equation, and without using these identities we cannot solve the trigonometric equation. Thus they are used to solve a trigonometric equation. Or we may be asked to prove an identity. In this case, we'll be given this symbol, which means is similar to. The context is that the left hand side is similar to the right hand side, although they may not seem equal, but by embedding some identity, we make them equal. And we will not solve both sides. Instead, we'll keep simplifying one of the sides until it becomes equal to the other. Now I'll just clear this off. Or rather, I'll just explain this, since these first two cases are simple. So this is what we have in here. This is an equation. So we need to bring a trigonometric function on one side, or the trigonometric functions on one side. So cos goes there, and we have sin x over cos x. Since we have two identities, we cannot solve this until and unless we recognize that we need to embed or introduce the first identity. So we had tan x is equals to 2 over 3. Tan goes to the other side to become tan inverse, and alpha, which is always positive, turns out to be 33.7 degrees. Since tan is positive in the first and third quadrant, we'll only consider these two angles. This is the range which we do not have to alter, and thus this is our final answer. Moving on, we have something like this. This seems complex, but you need to realize that both these things are cos, and you can take cos common. After taking cos common, we'll just solve for cos and this part separately. So cos x is equals to 0. We learned that whenever we have something like this, we'll not solve it. Instead, we'll use the graph to find the intersections. In this case, 90.0 degrees and 270 degrees are the values of x. Then we'll solve this part. Again, when sin x and cos x go to one side, we recognize that we need to introduce tan x. Solving for alpha will give us 26.6 degrees. Since tan, we won't consider sin x or cos x when determining the angles. So we'll consider tan. So the angles are 26.6 and 206.6 because tan is positive in the first and third quarter. So we write these answers in ascending order, and this is our final answer. Now, the second question is to prove these identities. Again, whenever you will be asked to prove an identity, you will have this sign which stands for is similar to. So let's start by simplifying this side. But before you start solving, just realize that everything on the right hand side is in terms of sign. Thus, we need to convert this in terms of sign. The left hand side should also be in terms of sign. So, replacing this, we have 1 minus sine square x. Sorry, this is a 2 sine x. So, we have 2 sine x minus 3. Or wait, this is a 3 sine x. I'm sorry. I'm really sorry. So, 3 sine x minus 3. Then we'll expand this part. So, we have 2 minus 2 sine square x plus 3 sine x minus 3. And 2 minus 3, thus we'll end up with this. And we prove the identity that the left hand side is equals to the right hand side. And thus you can think of yourself to be the king. Moving on, we have this. Now realize everything on the right hand side is in terms of cos. So we'll convert the sign in terms of cos. So we have 1 minus cos square x minus 5 cos x, which remains unchanged. Expanding the brackets gives us this. I'll just highlight this part so you recognize what I replaced. Now 2 minus 4 is minus 2, and this is what we're left with. The left hand side turns out to be equal to the right hand side, and you are the king. Now, the third identity. We have 5 identities in total, just so you know. So, this is our third last identity too. So, everything on the right hand side is in terms of sine and cos. Interesting. Two trigonometric functions. And we have tan on the left hand side. So, the identity which we know for tan is sine x over cos x is equals to tan. This whole thing is this over, let's remove the brackets, they are not needed, sine square x over cos square x, since we have a square here, plus 1. Now we can write this as sine x over cos x for this part, I'll Rather than writing this as a fraction, I'll use the division sign. Sine square x over cos square x plus 1. This reduces your chances of making a mistake. You have a division sign. This will turn out to be as a single fraction. Cos square x sine square x plus cos square x. Hmm. So we do know that we have an identity for this. So rewriting this, we have something like sine x cos x multiplied by the denominator becomes the numerator and the numerator becomes the denominator. So we replace this thing by 1. The cos square x, or rather the cos x cancels out with the cos square x to leave cos x. Thus we are left with our final identity. And notice that we have proved that the right hand side is equals to the left hand side. You're a king, bro, or a queen if you're a female. Then moving on, our second last our second last part of this question. Again, we have the right hand side in terms of cos. So we'll have to use the only identity we know for tan. Don't forget the square. I'll write this in a simpler form. Again, sine square x over cos square x plus 1. We have a division sign in between. This part as a single fraction can be written as this thing. And this part can be written as this. Since you're an A-level student, you should appreciate that you can directly cancel these cos square x's. Thus, we have sine square x plus 2 cos square x multiplied by 1 over, because after cancelling we'll have a 1 on both these fractions. 1 over sine, wait a second, this thing turns out to be 1 too. So we have 1 over 1. Alright, interesting. So we'll just simplify this part. So we have the right hand side in terms of cos again. Thus we'll write sine square x in terms of cos. And we turn out to have 1 plus cos square x. And you are the king. Or I am the king. Our last part is this. 1 plus cos x plus sin x. No wait. 1 plus cos x over sin x plus sin x over 1 plus cos x. Let's start by taking the lowest common multiple, shall we? So we have this. I'm doing this because I want to write this as a single fraction. This whole thing over this. Sin x 1 plus cos x. Alright, is equals to hmm, now. I can't cancel this. Thus, I'll rewrite this as something like, just a second. So I have, or rather here, so I can write sine square x as just a second, 1 minus cos square x. Hmm. So now, recap the identity which we learned in middle school, that a plus b whole square is a plus b, a plus b. But if we have a square minus b square, it's gonna be a plus b, a minus b. Since and once we are done with recapping this, just appreciate that this identity can be applied here. Thus, we have something like 1 plus cos x, 1 minus cos square, 1 minus cos x. Now you might be wondering that we don't have a square over 1, but appreciate that 1 square is equal to 1. Alright, let's take 1 plus cos x common. We have 1 plus cos x common. Just learn how to use brackets the proper way. And we have the denominator as it is. 1 plus cos x cancels out on 1 plus cos x. We'll solve this part. So 1 plus 1 is equals to 2. And the cos x's cancel out. So we have 2 over sine x. And this is exactly what we needed.